Suppose the difference between two numbers is 100. Minimize their product. So this is an example of an optimization problem. And in this problem, our goal is an objective function. In this case, we want to minimize something. So often the objective function is given as a minimize or a maximize. So here our objective is to minimize the product of two numbers. Now, before we can do anything, let's talk about these two numbers. Well, let's just say, what are they? So let's let our numbers, let's say that the numbers, so let's introduce some variables. All right, so our numbers let's just call them x and y. So our objective function is to minimize the product of two numbers. So our objective function let's call it P for product, and the product is equal to x times y. Now, an issue here is we haven't developed the calculus necessary to work with this function. Our objective function P is now a function of two variables, x and y, and we haven't learned how to deal with that yet. We've only learned how to deal with the calculus of a one variable function. So we can't do anything with this yet. Fortunately, we're given some more information. We are told that the difference between the two numbers is 100. That's called a constraint on the problem. So we have a constraint, and the constraint says that the difference between the two numbers is 100. Well, if the two numbers are x and y, and their difference is 100, then x minus y is equal to 100. So now what we can do is take this constraint and use it to substitute into the objective function to get that down to a function of one variable. So if x minus y is equal to 100, then y, let's see, if we add y to this side, we'd have to subtract 100. Y is equal to x minus 100. So now I can take this x minus 100 and I can use it to replace the y in the objective function, and now I'll have the objective function to be solely a function of one variable. So then the objective function becomes p of x, and it would be x times x minus 100. And so p of x is equal to x squared minus 100x. Now we can apply calculus on this. So if p of x is x squared minus 100x, p prime of x is 2x minus 100. And we can figure out where any of our critical numbers are. So if 2x minus 100 is equal to 0, x easily equals 50. Now, let's check, is that going to be a minimum or a maximum? And we can use the first derivative test. So if we test into 2x minus 100, here's my number line, and here's 50, and we're testing into p prime of x. Then if x is, say, 0, then I would have a negative number here, decreasing. And if x was, say, 100, I'd have a positive number here, increasing. So I have a minimum when x equals 50. All right, so then what that tells me then is if we have a minimum when x equals 50, so then if x equals 50, then y would be 50 minus 100. X minus 100, y equals negative 50, and the minimum product is P, which is equal to 50 by negative 50. The minimum product is negative 2,500.